Hello, my name is Chester Udell, and this is IMDL 2010 Fall with Schwartz and Arroyo. Yeah, Dr. Schwartz is right. I'm a PhD student in music composition, and these professors were kind enough to let me take some courses and learn in this field, so thanks to you guys. My robot's name is the MIRAG, which stands for Musically Intelligent Robotic Algorithmic Guitar. And as you can see here, there are 3 monochords, each tuned to D, F sharp, and A respectively. What you're going to see is this is a what one might call an autonomous musical agent, meaning that there's no preconceived score, there are no notes and rhythms in the processor. What is programmed in the processor are rules to generate music. These algorithms are derived from principles of counterpoint. Counterpoint are various rules and principles that composers like Bach and Haydn would have been extremely familiar with. And so this thing generates music based on those principles, those algorithms that I had programmed. Let me go ahead and run down the anatomy of one of these. I have a stepper motor that drives a node up and down, and this controls the pitch of the string. This servo plucks the string back and forth, and that's the thing that initiates the sound. These servos dampen the string such that if the sliding between the pitches is undesired, it can attenuate that somewhat. Okay, the next thing is the anatomy of the processor board. I have one MSP430, and this is the brain processor. This is the processor in which all the musical algorithms are generated, and it generates pitches based on various sensor data that I'll explain in just a moment. It sends the musical messages out to these reflex MSP430s, and they basically drive the stepper motors and send the control signals out to the actuators here. The sensors are a sonar, and the sonar detects people proximity. And so when someone approaches the robot wirelessly communicates with my computer here. This is my transceiver hub. And it says, okay, someone's standing in front of me. Let's go ahead and analyze the color of the shirt. And so my computer analyzes the color of my shirt and sends it back to the microprocessor. And the color of my shirt will be mapped to particular scale types. So the red scale, or the red color, will be the Hungarian minor or the gypsy scale. The green shirt is mapped to Dorian mode. If you guys are familiar with green sleeves, la 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 la, that is the Dorian mode. Okay, sounds very minor. Then the blue LED, that is mapped to the 5-pitch pentatonic scale. It sounds very oriental in nature, and so I will go ahead and run through that with you guys. This is the calibration sequence. When I turn this thing on, all the nodes will slowly approach fret 0. There are bump switches here that tell the brain, okay, I'm calibrated and ready to go, and then it starts generating counterpoint. When no one is standing in front of it, it will perform counterpoint in the major mode, which is a very, very common standard mode used in tonality. And then it plays phrases and cadences and then continues on. Okay, I'm going to go ahead and stand in front of this with a green shirt. This is mapped to the Dorian mode. And so the green LED begins blinking. Another interesting feature is the tempo. I can control the speed at which this thing plays based on the value of this photoresistor. So if I cover it up, it will start speeding up. And then if I step away, it begins playing in major. The next scale is the red shirt, and this is the gypsy scale, Hungarian minor. step away and it will begin to sound happy again and play in the major mode. And the final scale is the 5-note pentatonic scale. This sounds very oriental in nature. And I'll step away and we'll begin playing in major again. All right.
So what you going to do with this?
Thank you very much. So the name of the robot is the MIRAG, which is the musically intelligent. That's what the I stands for. Intelligence insinuates learning, and this is not what this robot is doing just yet. It isn't learning anything. So what I'd like to do eventually is program into it learning algorithms, where a musician can plug into a computer and perform, and this will begin to learn various patterns that a human performer would do and incorporate that into its musical algorithms.
Very cool. Okay.